Okay, in this video, we are going to be doing BC Calculus Review Quiz number 1. So let's take a look at the problems. Problem number 1. A particle moves in the xy plane in such a manner that its position at time t is x of t, y of t, where x of t is 4 cosine pi over 3t, and then dy dt. So we know the actual x coordinate. We only know the rate of change of y. dy dt is pi over 6 cosine pi over 3t. We want to find the particle speed at t equals 2. So I'm going to do something a little weird to start this problem off because we're given dy dt and it's not a convenient notation to use. I'm just going to make a let statement. I don't actually know that you need to do this because this is very generally accepted, but I'm going to say let y prime of t equal dy dt. The reason for that is I just want to use y prime instead of dy dt in like everything that I do. So I know that speed is going to be equal to the square root of dx dt squared plus dy dt squared. So in this case, it's x prime of 2 squared plus y prime of 2 squared. And now what I'm going to do is I'm going to switch over to the calculator, show you what I typed in, show you the setup, then I'll come back and I will write in the answer. So we found that the answer was approximately 3.637. Okay, let's take a look at the next part of this problem. So same setup. We want to find the particle's acceleration vector at t equals 4. So acceleration is the derivative of velocity. I'm going to write that down. So our acceleration vector will be v prime of t. And now we need to find this at 4, so I'm going to write that down. I'm going to say that a of 4 is going to be, in vector notation, x double prime of 4 comma y double prime of 4. And now what we need to do is switch back to the calculator to find this out. So take a look at that. And we found that a of 4 is approximately, to 3 decimal places, 2.193, comma 0.475. Okay, let's take a look at the next part. If y of 0 is equal to 3, we want to write the equation line tangent to the particle's path at t equals 0. So we're going to need to know the x-coordinate, the y-coordinate, and the slope to do this. So x of 0 is just going to be 4 cosine of 0, and the cosine of 0 is 1, so I'm just going to write that down as 4. I'm not going to use a calculator on that, but you really should use the calculator because you don't want to get something wrong when you could have just typed it into a calculator. All right, so in general, dy dx at t equals 0 is going to be y prime of 0 divided by x prime of 0, and let's go to the calculator and see what we get for that. Okay, so that's problematic. So it turns out that x prime of 0 is 0, which means we are dealing with a vertical line, right? So if x prime of 0 is 0, that means dy dx is undefined, which means that our tangent line is actually a vertical line. And so we just need to write the vertical line through t equals 0. The vertical line through t equals 0 is going to be whatever x was, which was 4. So our tangent line is going to be x equals 4. So that was a little bit surprising, but what are you going to do? All right, let's take a look at our next problem, which is problem number 2. Consider the polar curve r of theta equals 4 theta times sine of 3 theta between 0 and pi, and shown, it says above, but it's actually to the left here, with shaded region P, and we want to find the area of P. So to find the area of P, I'm going to need to know when P starts, when P stops, and then I will just set up my integral for that. So I'm going to switch over to the calculator, and you can watch what I do. Here we go. Okay, so now we need to write down what we found. So I'm going to make some let statements. I'm going to say let T1 be approximately 2.0944. T2 is actually just pi, so I'm just going to write that. Area in polar is going to be 1/2 the integral from where we start to where we stop, and then r squared d theta. And then we found that that was 28.860. And that's all you really need to do. Pretty okay problem. Let's take a look at the next part. Write the equation of the line tangent to r of theta at theta equals pi over 2. All right, so to do this, we're going to need to know the x-coordinate, the y-coordinate, and the slope. So in polar, it's essential that you walk in knowing how to convert polar to rectangular. So x of theta is going to be r of theta cosine of theta, and y of theta is going to be r of theta and then sine of theta. So you have to know those. We're going to need to know x of pi over 2 and y of pi over 2. We also need dy dx. So dy dx is going to be y prime of theta divided by x prime of theta. I'm going to end up using the calculator to get all of these in one shot. So what I'll do is I'm just going to end up filling these in at pi over 2. Let's switch to the calculator, see what values we get, see how I did that, and then I'll be back and I will write in some things. All right, so filling in the values that we found, we got x is actually 0, not approximately 0. Y is approximately negative 6.283, and dy dx is approximately negative 0.637. So now we just need to write the tangent line. Don't confuse the value of theta with the value of x when you do this. It's the same as when you're doing parametric lines. Don't confuse t with x. You want to avoid that mistake at all costs. Very common. So our tangent line will just be y minus y0 equals m x minus x0. X is 0, y is negative 6.283, and the slope is negative 0.637. There you go. All right, let's take a look at part C here. Particle moves along r of theta such that at time t, d theta dt is equal to 2 for all t between 0 and 2 pi. It's actually between 0 and pi because this doesn't even move between pi and 2 pi. Describe the particle's motion at t equals 5 pi over 6. We want to consider the particle's position relative to the coordinate axes and the origin. All right, so to do this, we need to know x, dx dt, y, dy dt, r, dr dt. And remember, x, y, and r are currently functions of theta. So we have to remember to use the chain rule to find, dr dt, dx dt, dy dt. So let's write down the things that we know. Borrowing from the previous one, we know that this is x and y. So what we're going to have to do is we're going to have to plug in 5 pi over 6. I'm going to use a calculator to do all those at once. So we'll need to know these. X prime of t, we need to use the chain rule on. So x prime of t is going to be dx d theta times d theta dt. On the AP exam, they like to ask these sort of like related rates type questions about this stuff. Y is going to be the same thing. So just keep that in mind, right? X is by itself a function of theta, but we're looking for dx dt, not dx d theta. So we're going to have to work that out. So we get both of these. And then, of course, we'll have to evaluate those at 5 pi over 6. I'm going to do that again in one shot on the calculator. We also need to know r of 5 pi over 6. And then we're going to need to know r prime of t. R suffers from the same thing. R is actually a function of theta. So to get r prime of t, we're going to do dr d theta times d theta dt. Luckily, d theta dt is just 2, so I just have to take like every calculation I would do and multiply by 2. Not really a big deal, but kind of a pain in the neck. And then we'll evaluate this at 5 pi over 6. So I'm going to switch to the calculator and just do like all of those in one shot, come back, fill in all of the values, and then try to write up our answer. And here goes. I'm just going to fill them all in one shot. You don't have to watch me write them. There you go. That's all the values that we found. Now we need to write this up. So at t is equal to 5 pi over 6. So think about x. X is negative and dx dt is negative. So let's write that down. X is less than 0, dx dt less than 0. So since x is negative, you are to the left of the y-axis. Since dx dt is negative, you're moving to the left. So you're getting farther from the y-axis. So I'm going to say that we are moving away from the y-axis. At the same time, y is greater than 0 because y is 5.236. dy dt is negative. So let's write that down. Y is greater than 0, dy dt is negative. So y is positive, you're above the x-axis. dy dt is negative, so you're moving down, so you're moving toward the x-axis. So you have to consider both of them when you do this. It's kind of like when you're talking about speed, right? You need to know the velocity and the acceleration to really make a determination. And then finally for r, we get that r is positive, dr dt is also positive, so that means that we are going to be moving away from the origin. So moving away from the origin. It's got a lot going on in this problem. I mean, this is really like 3 problems in one. Not terrible though, so I hope you followed along with that. All right, let's take a look at the third and final problem for this quiz. Let f be a function that has derivatives of all orders for all real numbers. We're going to assume f of 0 is 8, f prime of 0 is -5, f double prime is 1, and f triple prime is 6. Whew. Write the third degree Taylor polynomial for f at x equals 0. Use it to approximate f of -0.2. All right, so you got to walk in knowing this, right? It's the nth derivative divided by n factorial x minus a to the n. That's going to be each term of this thing. So f of x is approximately the 0th derivative over 0 factorial x to the 0, or x minus 0 to the 0, which is just 8. Then we're going to have the first derivative over 1 factorial x minus 0 to the first, so -5 over 1 factorial, and then x minus 0 to the first. Then we do it for the second derivative, so it's going to be the second derivative over 2 factorial x minus 0 to the second, so that's going to be 1 over 2 factorial, and x minus 0 to the second. I always write the minus 0 even though you don't need it. And then it'll be the third derivative over 3 factorial and to the third. So 6 over 3 factorial, which actually is 6, but x minus 0 to the third. All right, so we actually don't need to simplify that for the purposes of the AP exam, so I'm just going to leave it the way it is to find an approximation of f of -0.2. f of -0.2, just replace every x that you see above with -0.2. So we're going to get 8 minus 5, -0.2 to the first, and then 1/2, -0.2 squared, and then I wrote 6 over 3 factorial. That's actually just 1, but there we go. All right, so that's what we got for part A. Pretty straightforward. Let's take a look at part B. We want to write the 6th degree Taylor polynomial for G, where G is f of x cubed centered at x equals 0. So I'm going to import what I wrote for f of x. F of x, I only need it to the second degree, because what I'm going to do is I'm going to replace every x that I see with x cubed, and when I do x cubed squared, I get x to the 6, which is the degree that I'm looking for. So I'm going to say that g of x, just replace every x that you see in our f of x with x cubed. So it'll be 8 minus 5x cubed plus 1/2, and then the quantity x cubed squared. And then we can kind of simplify this to 8 minus 5x cubed plus 1/2 x to the 6th. It's a pretty straightforward problem. I see people get really scared of the series questions. There's really no reason to feel that way. Just learn a couple of the basics and you can apply them over and over again. Let's take a look at the next part. Write the third degree Taylor polynomial for h, where h of x is the integral from 0 to x of f of t dt at x equals 0. All right, again, we're going to need f. So here's f. Since we only need third degree when we integrate, we only need to go up to second degree here because the power rule, we're going to add 1 and multiply by the reciprocal. Add 1 to 2, you get 3, which is the degree that we need. So I'm going to write out a couple of steps on this, I guess. I'm going to say that h of x is the thing that we were told, right? So from 0 to x, that's a definite integral, by the way, which means that there isn't going to be a plus c. Now, we can only approximate this because we don't actually know what f is, so we'll say it's approximately the integral from 0 to x of, change all the x's to t's, that's a dummy variable. I don't really think you would lose points if you forget to do that, but like try not to forget. Now we have to integrate this, right? So you're going to get 8t minus 5/2 t squared plus 1/2 times 1/3 is 1/6 t cubed, plug in x, and we get 8x minus 5/2 x squared plus 1/6 x cubed, plug in 0, and everything goes away. So all that we're going to be left with, so I said all that out loud because usually I just don't show that step, because when you plug in x, it just changes every t into an x, and when you plug in the center, regardless of what the center is, it will just cancel it out every time. So here I've gotten 8x minus 5/2 x squared plus 1/6 x cubed. Very common type of problem. All right, let's take a look at the last part of this thing. Let h be the function defined in part C. So h is this thing. Given that f of 1 is 2, either find the exact value of h of 1 or explain why it cannot be determined. So the center of our function, of our series, or our polynomial, the center of our polynomial is 0. That is the only place that you can find exact values. So we cannot find the exact value of h of 1. So I'm going to say h of 1 can't be found exactly because we can only find exact values at the center, which is 0. So if we were asked for like h prime of 0, h double prime of 0, those are things that we could actually find out. We can't find the exact value anywhere except the center. All right, so that's it. I hope you found this helpful, and good luck.